So I'm picking up on objective 18. We are going to finish solving triangles using the law of sines. So I want you to remember, because on your um, next test, like, I'm going to give you lots of different triangles. And so my thought is, if I give you a right triangle, how are you going to solve that triangle? We're going to use Pythagorean theorem. We're going to use our trig functions. We know that the sine is we're going to use SOHCAHTOA basically, okay? We know the sine is the opposite over the hypotenuse. We know the adjacent is the adjacent over the hypotenuse. That's if it is a right triangle. So what the law of sines does, each law that we have, like when we go into the law of cosines, there are certain triangles that you can solve using the law of sines. There are certain triangles that you can solve using your trig functions. Those are right triangles. And then, like we looked at some the other day, that you would not be able to solve using the law of sines. And those you're going to be able to solve using the law of cosines. So I just kind of want to review that with you. So we went through these examples. Here was the law of sines. It says this, basically, that the lengths of the sides are proportional to the opposite angles. Okay, so we can say the sine of angle A divided by the opposite side of that angle is equal to the sine of angle B divided by the opposite side B equals the sine of angle C divided by the side opposite of angle C. Okay, you're not going to use all three at one time. Okay, basically you're going to use any two pairs of them. Does that make sense? So you might use the sine of A over A is equal to the sine of B over B. Or you might be able to say the sine of B over B is equal to the sine of C over C. Okay? Does that make sense? You'll either use two sets of them or or you could even take out the B and do the sine of A over A is equal to the sine of C over C. And then you'll have a proportion and you'll be able to cross multiply and solve for your missing pieces. We talked the other day about which triangles, like, you're going to have to know when you look at a triangle, which information do I have? Do I use the law of sines, or do I use the law of cosines, or do I use our trig functions with right triangles? Okay, so in this case, we determined the other day, in order to do the law of sines, you have to have at least what? You need to have at least one angle and any two sides. Like here, I've got, like, let's look at this one. If I look at this pair right here, I mean, this has a angle and two sides, but in order to use the law of sines, you've got to have an angle and a corresponding side. So I would need to have this side in order to be, so you could set up the sine of A over the side of A, and then you could say, I don't know, the sine of C over the opposite side of C. Does that make sense? And then you'd be able to figure it out. But in this case, because I don't have a corresponding angle with a corresponding side and at least another side, then you cannot do, so this one would be a no. You cannot do the law of sines with that one. Okay, does that make sense? What you will be, so if we can't do the law of sines, how will we solve this one? The law of cosines, and that's what we're going to learn next. Does that make sense? I'll show you how to solve a triangle, but you can't do the law of sines with a triangle like this, okay? How about this one up here? Can you use the law of sines? Yes, because you've got a corresponding angle, a corresponding side, and then another side, and then you would be able to find this missing angle, and then from there you would be able to use your all angles in a triangle add up to be 180 to find the other angle, and vice versa, and finish it out. Okay, what about this? You don't have an angle at all. You got to have at least one angle with a corresponding side and another side or angle in order to be able to do the law of sines. So my question is, this one is a no. You can't do it by law of sines. So how will we solve this one? Well, is it going to give you your, you can't use Pythagorean theorem unless they're what? right angles, and you don't know necessarily that this is a right angle. So you can't use Pythagorean theorem, but you'll be able, this is one that I will be able to show you how to do law of cosines. No, but what I will do is I'll give you triangles, and I'll say solve that triangle, and I'm not going to say how, and you're going to have to say, well, this is the information I have. I can do law of cosines there. Does that make sense? So I'll talk more about that as we get into law of cosines, but that's kind of what I wanted you to know is we're going to be able to do different triangles, solve them different ways, okay? So today we're focusing on law of sines, okay? We did this one. I'm going to pick up on this one, okay? I asked you to do this one by yourself, and I told you on Friday that we would pick up here. So I'm actually going to work this one out for you, and then we'll roll on, okay? So, where do we want to start? It doesn't matter. I mean, what do you want to start? What do you want to find first? Okay, you want to find side A. Okay, sure. So we can say the sine of what? Which is the, if I'm looking, okay, so you're going to start with C? It doesn't matter. Okay, so he said sine of 25, that's your C, divided by, what's the side that's opposite from C? So you got to use that side right there. So 80.4. And if we're going to find A, we would use the sine of what? 20 divided by A. And so we're going to solve for that. Okay, any questions on what I did and how I set that up? So we're going to plug this in our calculator, and we're going to just cross multiply here. Okay, I did tell everybody that was here on Friday, like if you could go back to what I normally say, like, ooh, yuck, gross, disgusting, nasty, let's multiply by our common denominator, which would be 80.4a. And that's fine if you want to solve it that way. But when it's a proportion, and when I say proportion, I mean a fraction equaling a fraction, then I just cross multiply because that seems easier. Okay, so the sine of 25a, and then here I'm going to do the sine of 20. And I did say this, your calculator is going to automatically throw a parenthesis right there. So before you do times 80.4, if you do that and you don't close your parenthesis, it will not work. So you got to make sure you close that and make sure it just does just the sine of 20. Okay? So how would I solve for A? I'm going to divide by the sine of 25. All right. So I'm going to do this in pieces and parts with my calculator. Okay? So, and maybe this will help you, Reagan. Okay? Like I do each piece. So let's first do the sine of 20, and everybody hit enter. Everybody put in the sine of 20 and hit enter. Maybe I should do this too. So sine of 20, and I'm going to hit enter. That way I know I have calculated the sine of just 20. Then I'm going to times that by 80.4, and I'm going to hit enter. That's my entire numerator. What do you have so far? 27.498. Okay. And then I'm going to click divide, and I'm going to divide by the sine of 25. And let's just round to the nearest tenth. So I got 65.1. How'd you do, Reagan? Good? Okay. This parenthesis right there, I think, because what it will do, it'll do the sine of that times that if you don't close this parenthesis. Okay? All right, where do you want to go to next? You want to go to B, or do you want to find, we probably, before we find the side of B, what do we got to find? We got to find the angle B. Okay? So, somebody tell me what the angle of B would be. Say it again. 135. How'd you get that? Any questions on how we do that? Three angles in a triangle add up to be 180. All right, so now let's set it up. And you can use either side. It should work. Okay, so you can use A or C. I'm going to stick with C. Like, I just tend to like the one that I've been given, and that's the one I use for everything. Does that make sense? The angle with the adjacent or the corresponding side. So the sine of 25 over 80.4 is equal to the sine of what? 135. I'm going to scratch that out so I don't have to erase. Divided by D. Okay, then we're going to cross multiply. The sine of 25 times B is equal to the sine of 135 times 80.4. And again, if you're going to use the parentheses, make sure you close it around 135. Divided by the sine of 25 on both sides. Okay, again, I like to work this piece by piece, so I'm going to put in sine of 135, click enter, then I'm going to times that by 80.4, and I got 56.85, and then I'm going to divide all that by the sine of 25. What do you get? 134.5. And I will tell you, like, you, especially when you get into the law of cosines, oh, I don't want to say too much too soon, but I will tell you it's possible that you set up your problem completely mathematically correct and get the wrong answer. And everybody's like, don't tell us that, Miss Corns. But here's what I want to tell you. What I want to get you in the habit of is we know that the largest angle has to be opposite from the largest side. So here's what I'm going to tell you. All you got to do when we get to law of cosines is when we get our answers, you have to look at it and ask yourself, does this make sense? If it makes sense, then you did it the right way. If when you work it out and plug it in, even though you set it up correctly, if you work it out and it doesn't make sense, and when I say make sense, I mean we need to just make sure, like look at our largest angle here. Is it opposite our largest side? Yes. Look at our smallest angle. Is it opposite the smallest side? Does that make sense? Do the three angles in the triangle. Like it's possible that you work it out and you get some crazy angle that it would not be able to add up to be 180. So if that happens, you know don't do it that way. Go and do it the other way. So I just want you to get in the habit of always looking at your answers and making sure that they make sense. And the opposite sides of the largest angle is the opposite of the largest side. Okay, and vice versa. Okay. So what if you have one that looks like this? Do you want to attempt it first? Yes. Good. How many drew a picture? Yay, good. That's step one, okay? So I wanted to see, without me telling you, like if you try to set this up and you don't draw the picture, it's going to be a struggle for you. Always draw the picture, okay? So I'm going to make this 45 degrees. We know the side opposite is 7 square root of 2. And we know the side opposite here is 7. So where are we going to have to start on this one? Well, I'm going to have to use A, obviously. And I've got this side of B, so I'm going to have to start with finding angle B. Do you understand that? So I could say the sine of 45 over what? 7 square root of 2 equals the sine of B over 7. So far, so good. And then I'm going to cross multiply. So this will be the sine of 45 times 7. Make sure you put parentheses around the 45 equals the sine of B times 7 square root of 2. Okay, what do I need to do now? I need to divide by 7 square root of 2. All right, so here is what I would do. This is going to give me the sine of B. So far, so good. In my calculator, I'm going to put in the sine of 45. I'm going to hit enter. Then I'm going to times that by 7 and hit enter again. and then I'm going to divide it by 7 square root of 2. 1. Okay, now there will be times that it comes out to be a big, long decimal. If you get a big, long decimal, you need to write every decimal place out. And I know you're not going to like that, but you need to, because if you try to find the sign of, I don't know, like if you round it to 0.9, your angle degree is going to be way off. You need to make it the sign of 0.98724, da 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 da, and that way your angle degree will be very accurate. Do you understand what I'm saying? So don't round it off. Okay, so my question is how do I want to get what B is, angle B. So how do I get rid of sine? We need to do the inverse, which would be sine to the negative 1. So I'm going to do sine to the negative 1 of 1. And when I do it to over here, the signs will cancel, leaving me with B. So in my calculator, I'm going to do the inverse sine of 1. And you tell me, what's my angle degree? 90. Okay, now obviously I did not draw my picture great, and you won't always know to do that. So you could, knowing what you know, tell me what would the angle C be? Say it again. 45. I think this is a 45, 45, 90. And being really smart, what do you think this side is? Why 7 square root of 2? Because it's going to be the same. Okay, now, so I encourage you, you know, like if you know, and so actually in this case, could your right triangle stuff work? Yes, it could, okay? But you could set up it again to find the sine, like you could use the sine of 45 over 7 square root of 2 equals the sine of 45, but you'll come out with a decimal, but really it's 7 square root of 2. It'll be the same thing. Does that make sense? Like I'd accept either or probably. So in this case, just the angle measurements, does that make sense? Turned out to be a right triangle. So I agree, it's not oblique, but it just, the way it worked, it did work out to be a 90-degree angle. Okay? All right, let's try one last one and see how you feel about it. This one is not going to come out as a right triangle. It probably will have some decimals. Again, just don't round early. Okay? Don't round early. Round at the end. All right. So let's just see if we get the first part right. Okay? And then I'll let you keep going for the second part. Okay? So does everybody understand why you have to find B first? Okay. So does everybody understand why we're not going to find C first? Why can't we find C first? You don't have the angle or the side. You got to have at least one of the pieces or parts in order to find either the angle or the side. So we're going to find B first, and I'm going to cross multiply here. And this is going to be the sine of 43.1 times 248.6. Okay? I'm going to put parentheses around that, equals the sine of B times 186.2. Okay? So what are we going to do to get the sine of B by itself? This isn't the sine of 186. This is just the sine of B. Does that make sense? So I got to get rid of this first. Okay? So I'm just going to divide by 186.2. Okay? Does that make sense? Okay, so those will cancel, and this will give me the sine of B. Now, here's where I was talking about the decimal part. When I put this in, I did the sine of 43.1, hit enter, times 248.6, hit enter, divided by 186.2, hit enter. You're going to get a really long decimal. Don't round that. If you round it right now, your angle measurements are going to be way, 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 way off, like so much off that your answer is going to be wrong. Okay, and then like I'll give you a quiz and you'll have all your roundings right. Even though you're doing it right, you're just rounding too early, but it's going to throw your problem extremely off, okay? So make sure right here, this is 0.912254888. You with me? Yes, no, maybe so? Okay, so my question is, how do I get rid of, I want to solve for b. How do I get rid of sign? The sign to the negative one. The inverse of sign to the negative one of this number, and then when I times that to that, there they will go. They will cancel, and you will get b. So if you put in the inverse sign of 0.912254888, you get what? 65. Now here's where you can round, because you're at the end of your problem. Does that make sense? Here's where you can round. You can make this 65.8. So that's 65.8. Any questions so far? This is capital B is your angle. Okay, if it's a lowercase b, it is the side. So because this is a capital B, that means I'm solving for the angle. Okay? All right, do I need to give you a minute to solve for the other piece? Okay, so how many did that one actually correct? Good? Yes, good. All right, so what's my third angle? Let's start there. 71.1. Let me ask you this. This would be a good, like SAT question. They might give you this, and they might say, which of the following answers would make the most sense to be angle C? Like, what can you tell me about angle C? Or not, the side opposite of C, sorry. It's going to be the biggest, so it's got to be bigger than 248.6. Like, I could see them on the SAT giving you like 4 choices for a side and them saying, you know, which side could this be? And you would have to pick the biggest, okay? Most people think on an SAT that you have to sit there and work like all this math out. And most of it is like just looking at it and saying, oh, well, I know that this has to be the longest side, so this is the only answer that makes sense. Click it and move on. Does that make sense? When you do your SAT. So just a little side note on that. So I want to find C, so I'm going to use that. Sine of 71.1 divided by C. Which side did you use? Which other pair? Okay. So sine of 43.1 divided by 186.2. Okay. I'm going to cross multiply. All right. So this is the sine of 71.1 times 186.2 equals the sine of 43.1 times C. Okay, so Jacob, what would I do to solve for this? How do I get C by itself? So can I just throw them over and add or subtract them? They're being multiplied, so how do I get, I'm going to divide by the sine of 43.1. Very good. Okay. So those will cancel and you'll get C. And so in your calculators, you need to do, and I encourage you to do this with me, to make sure you're putting it in correctly, because that's an issue sometimes. The sine of 71.1, hit enter, times by 186.2, hit enter, and divide it by the sine of 43.1. Hit enter. And what do we get? Does it make sense that our answer would be 257.8? Because what did you tell me you knew about that side? It's going to be the largest. Because, again, I'm trying to, like, condition you so that when we get into laws of cosines, and I'm telling you, you set it up, you work it out completely correct, but your answer doesn't make sense. So just because you plug it in and work it doesn't always mean it works. So it's kind of like those extraneous solutions y'all had in Algebra 2, right? Just because you do it right doesn't mean it always works. You always have to go back in and make sure that it makes sense and that it checks out. Okay? All right. Last one, and we're going to stop for the day. Okay, last one, we're going to stop for the day.